Lucy is shopping for a sports utility vehicle, which is an SUV, which blows people's minds because they don't know that SUV stands for that. So that's a little life lesson right there. Good job. SUV, if that makes your heart a little bit better. Okay. The dealer says that he has 3 different models. Okay. And that each model comes in 5 different colors. We have to complete the tree diagram to determine how many different choices Lucy has. So when she walks out and she's deciding, she has how many different choices can she choose from, right? So we're going to do a tree diagram. The problem with tree diagrams is that everyone wants to draw them like a tree, which is vertical. But tree diagrams are actually drawn horizontal. And I think they're called tree diagrams because they look like branches. They don't really look like trees. So don't draw them vertical, which everyone does, and they can't get them to work. Okay, they go horizontal. They work out. Okay, so you always put the title at the top. So at the top we have model. Our other option is color. And then our last thing is, what are the choices that she has? That's what we'll do. Okay, so if there was 3 parts, say it was a robot you were building, and there's a top and a middle and a bottom. You put the top, you put the middle options, and the bottom. Okay, so you always list the options along the top. So here we listed model and color. So they said that there was 3 different models. So our option was the Cross 4, the X Ground, and the Trail Pro. Those were the 3 options. And do you see how they put big spaces in between them? They put big spaces because they're going to have 5 little branches off of each one. If you put them really close, it's never going to work, right? Because it's getting bigger. So you want to expand those first parts of the tree. You want to make farther apart. So Cross 4, X Ground, and Trail Pro. And then it said there was 5 different color options, right? So there's blue, red, silver, white, black. Then for the X Ground, there's blue, red, silver, white, black. And then for the Trail Pro, there's blue, red, silver, white, and black. Okay? And then all they did at the end was they wrote all the different options. So a Cross 4 in blue, a Cross 4 in red, a Cross 4 in silver, a Cross 4 in white, a Cross 4 in black. How many options of Cross 4s were there? 5. Then you have an X Ground in blue, an X Ground in red, an X Ground in silver, an X Ground in white, an X Ground in black. How many options? 5. And then a Trail Pro in blue, Trail Pro in red, Trail Pro in silver, Trail Pro in white, Trail Pro in black. So we have 5 options again, right? So how many total options did she have? 15. Sound good? Now you must think in your head there must be a better way, because like this is time consuming. And if I add another 3rd part, I'd have branches off of the branches, right? And it would take forever. So there must be a better way. We're getting into the fundamental counting principle. And the fundamental counting principle says that if you have different parts of something that make a whole, so for example, this is a model and the color, that if you multiply the options, you'll get the total number. So say we had a robot with 2 colors for the head, 3 colors for the middle, 2 colors for the feet. We could just go 2 times 3 times 2 and it would give us all the outcomes. So if there's a whole bunch of parts and you pick one of each of those parts, you can just multiply them together and it would get you the whole thing. Okay? So in this case, part 1 was the model. And part 2 is the color. How many models were there? 3. How many colors were there? 5. You need this and this, so you multiply them. It's 15. Now, if I wanted a specific outcome, like what it actually is, I would have to draw the trees, because that gives me actually what each outcome is. If I just want to know how many there are, I can just multiply them. Okay? So here's what the fundamental counting principle says. It's right here. You don't need to memorize it, but this is what it says. It says, consider a task made up of several stages. The fundamental counting principle states that the number of choices for the first stage is A, the number of choices for the second stage is B, the number of choices for the third stage is C. You can multiply them together and get the total number. That's what it says. Okay? Yeah. How did I not give you guys that? Sorry. Okay. So let's look at class example 1. A toy manufacturer makes a wooden toy in 3 parts. Part 1, the top must be colored in red or blue. Okay, so let's deal with that. So at the top, we're going to write part 1. I don't know why I wrote it. It should be written across above these. So above red, we're going to have part 1. Then we're going to have part 2. Then we're going to have part 3. Yeah? And then you list the options below those. Okay? So what a lot of people want to do is they want to list red and blue at the top. That's not what we're doing. We list part 1 and then we list the options of part 1. Red, blue. Okay? So your trees are going to go out sideways. So you have part 1, red, blue. Then part 2 says the middle part can be orange, white, or black. So off of each red and blue, we're going to have 3 branches, right? Orange, white, or black. Orange. And we want to leave spaces off of these because we're going to have another tree piece off that. And then blue, we have 3 off. Orange, white, black. And then off of those, we're going to have little branches, right? Ooh. Part 3. Part 3 is how many options? Yellow or green? So off of each of these, I'm going to have 2 options, right? So what would the outcomes be? If you follow them along, you'll see what the outcomes could be. I could have a top that's red, a middle that's orange, a bottom that's yellow. I could have a top that's red, a middle that's orange, and a bottom that's green. I could have a top that's red, a middle that's white, a bottom that's yellow. Red, white, green. Red, black, yellow, red, black, green. Are all those different? Yes. Then blue, orange, yellow, blue, orange, green. Blue, white, yellow, blue, white, green. Blue, black, yellow, blue, black, green. So how many options do they have? 12. You could just count these, right? Because that's where you're going to end up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 different toys. So then we're going to use the fundamental counting principle so we don't have to do this, right? If we have different parts that make a whole, if we just say how many of each of them are, and we multiply them, we'll get the total number of outcomes, correct? If we're just picking one of each. So we're picking one top, one middle, one bottom. If we picked like two tops, one middle, and one bottom, then we couldn't use the fundamental counting principle. Okay, but we're picking one top, one middle, one bottom. So this would be the top, middle, bottom. And those parts, we need one of each of those parts to make the whole toy, correct? So then we can find out how many, multiply, and we have our answer. So how many different tops can there be? 2. So up here above the line, we always state how many options there are, not how many we chose. We aren't choosing two tops at a time, right? We're choosing one top at a time, but how many do we have to choose from? 2. So above the line is always how many options you have. So I have 2 options. The middle, how many options do I have? And the bottom? And what's 2 times 3 times 2? 12. On diplomas, I've seen it so far as they would say something like, they give you pieces of a whole instead of like the whole. So for example, they would say, okay, I have a bottom, or on the top, there's 2 options. The middle, there's 4 options. How many bottom options are there if there are a total of 24 toys? So instead of giving you the 3 options and getting you to multiply them, they gave you the total number and 2 options, and now you have to find the third. How do we do that? Anyone know? Yeah. You're right, because we could treat this like it's an x, correct? And 4 times 2 is 8, so we'd have 8x equals 24. So you can either say to yourself, okay, what times 8 is 24, which is 3, or you could say, I want to just solve it by algebra, x equals 3. So then I would have to have 3 options for bottoms. Okay, not a hard question, just a tweak on the question, right? And that's the difference in the diploma style questions as opposed to previous questions. Okay, the catch with diploma style questions as well is the 3 answers are common errors. So there's not like a crazy random answer that you know is not correct. If you don't know your stuff backwards and forwards and you make the common mistake, the answer will be there and you'll think, yay, I got it, but you actually picked the wrong answer. So that's why you need to know everything backwards and forwards so you don't fall to the common errors that they have there. Okay? So let's look at this question. A math quiz consists of 6 multiple choice questions. So we know we have 6 multiple choice questions. Each question has the choices A, B, C, or D, so 4 choices. Use the fundamental counting principle to determine how many different set of answers are possible, like how many different answer keys you could have. So some people will say to me, oh, it's really easy to, even if I didn't study, I could probably figure out the answer key. It's only 8 questions. Not true. So this one here is 6 questions. So how many parts, not like multiple choice numeric and written, how many parts, like different questions, does this test have? 6. So how many blanks are we going to have? 6. Each question is a different part of the test, correct? So this would be multiple choice 1, 2, 3, 4, 5, 6. Remember, we always state above them the amount of options we have, not how many we pick, but how many options there are in that spot, in that part, correct? So how many options are there in 1? 4. And in 2? 4. And in 3? And 4? And 5? And 6. Now they could give us a restriction. They could say the answer to multiple choice 1 is A. And then how many options would we have for the first blank? If it's just, it has to be A. 1. Yeah. Okay. So they can restrict you in certain ways as well. Now, we have to decide, do we multiply or add? Well, so far we've always multiplied. But the reason why we multiply is you multiply whenever you use the word and. So up here it says and multiplying. So you have to ask yourself, on the test, is there this question and 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 this question? Or on the test, is there this question or this question or this question or this question? Would it be and or on the test? And. It's not or, because that would mean that you have the option to do those questions. Do you have the option to do 1 or 2 or 3? No, your teacher doesn't let you. And they didn't say that. They didn't say you could pick 4 out of 6 or something like that, right? So you're doing every single question. So you have to do this question and this question and. So that's actually 4 to the what? 6. Or you could go 4 times 4 times 4 times 4 times 4 times 4. I think that's 6 of them. What if the answer was this and you're like, oh goodness, I don't know. Well, could you not go 4 times 4 times 4 times 4 times 4 times 4, get an answer, turn that into an answer, match the answers? Could you not? So just because your answer isn't like theirs doesn't mean you can't turn this into an answer. Check your answer and match them, right? So what's 4 to the 6? Anyone in their calculator? No, 4 to the 6 is 4 times 4 times 4. Thank you. So just a 6 question multiple choice test with answers A, B, and C, and D have 4,096 answer keys, different answer keys. So you getting the correct answer key is 1 out of 4,096. So if you think you're going to, like, in sequences and series in 20-1, you could kind of outsmart the question. Even if I gave you really large numbers, you could just draw like 800 blanks and then figure out the thing that way and go about and not use the formula. You could just do that. You'd have to like do 4,096. You're probably going to miss a couple or a few hundred. Okay, so you have to know how to do these because they're really large answers. Okay, before we get to this, I'm going to get you to work on partial homework, and then we're going to come back to notes, then homework, then notes, then homework, then notes, okay? Okay, so it's not example 9. This is my 30-1. Where are you? Here. Okay, we'll go here. Example 3, actually. Sorry. Example 3. So when solving problems involving restrictions, it's important that the restriction be dealt with first. This has to happen. So a restriction would be like the first answer has to be A, or the last answer can be B or C, or it has to start with a red car, or it has to end in a blue car, or something like that. Those are restrictions. So if there's a restriction, you have to deal with it first, okay? And then you deal with the rest. So we have here, Eric has been assigned the task of determining how many odd 4-digit numbers there are. Now, let's get through this, what the heck this means. Odd. How can you tell a number is odd? Yeah. Doesn't divide by 2. What else? $23, odd or even? 24, odd or even? 25, odd or even? 26, 27. What am I changing? The last digit. All that makes something odd or even is your last digit has to be odd or even. And indirectly, that makes it divisible by 2 or not. Okay? So when it says that he has to have odd 4-digit numbers, odd just means the last digit must be odd. So 1, 3, 5, 7, or 9. Okay? We wouldn't do 11 because that's actually a 2-digit number and that would take more than 1 digit, right? So if it says it's odd, it has to end in an odd number. Now it says that it's a 4-digit number. That's also very, very important. A 4-digit number tells you something. What is an example of a 4-digit number? Anyone? 4-digit number. 1,000. That's a 4-digit number. Any other one? 1, 2, 3, 4. Someone told me before. That's a 4-digit number, right? 1, 2, 3, 4. Is 0, 1, 2, 3, 4 a 4-digit number? Some people will say yes, but if you think about it in money, $1,234 is a 4-digit number, right? 0, 1, 2, 3 is $123. You're making way less money. We agree? So when it says that it has to be a 4-digit number, the stipulation, when it says that, it's indirectly giving you a restriction. The restriction that it's giving you is that the first digit cannot be 0. Because if it is 0, it's a hidden 3-digit number. That's all it is, right? It's not a 4-digit number. It's a 3-digit number with a 0 in front. Okay, so if they say 4-digit number, 5-digit number, 7-digit number, 3-digit number, all they're telling you is that you need to have 4 blanks and the first blank can't be 0. That's the indirect restriction they're giving you. And they're not going to say that. They're not going to say the first blank can't be 0. I did it here, but they're not going to tell you that on the diploma. So 4-digit number means 4 blanks. And the first can't be 0. So this actually has 4 blanks and 2 restrictions, correct? The first restriction, 0 can't be in the first blank. The last restriction, the last digit can only be 1, 3, 5, 7, or 9. Okay? So let's read through it. He has been told, and you will not be told this, such a number such as 5267 is a 4-digit number, where 0267 is classified as a 3-digit. So I'm not going to worry about going through the work as shown. We're just going to do the answer down here. So 4 blanks, right? 4-digit number. Above the blanks, you will always list how many options you have to fill into that blank. Below the blank, you will list the actual options. Okay? So in this last blank, what numbers can I put in it? What possible numbers? 1, 3, 5, 7, 9. So below the blank, I always list my options. Above the blank, I put the number of them. How many of them are there? 5. So I put a 5 up here. Does it mean that I leave the number 5 there? No. Does it mean that I leave 5 numbers there? No. All it means is that there's 5 options for that last blank, right? Because we always just list the options above the different parts. That's what we've done so far. Okay, our other restriction we have to deal with is the first blank. The restriction is that it can't be a 0 or it would be a 3-digit number. Yeah? So we have the options 1 to 9. How many numbers are there from 1 to 9? Use your fingers if you have to. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's actually 9 options, right? When you use all those numbers, that's 9 options. Put a 9 above. Did it say anything about you can't repeat the numbers? No. If it doesn't say you can't repeat, you just assume you can. It's not going to say you can repeat the numbers. The only way you know you can't repeat the numbers is if it says you can't repeat them. If it says nothing, you assume that you can. Okay? They're never going to say you can repeat the numbers. They just won't say you can't. What are the options for the 2 middle ones? And we're doing the 2 middle ones last because there's no restrictions. So what numbers could we put in there? 1 to 9 and 0. So 0 to 9. How many numbers is that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You messed up somewhere there. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 options, right? And this one's 0 to 9 again. And what do we do with all these parts? We multiply them because we need each of those parts. We need the first digit and the second digit and the third digit and the fourth digit to get all digits, right? So we multiply them. So it's 4,500. So there are 4,500 odd 4-digit numbers in the world. B. Here's the twist. Eric has now been assigned the task of determining how many odd 4-digit numbers there are. Which have no repeating digits. So that's our difference. No repeating digits. Everything else is the same, correct? Same restriction. We can't start with a 0. We have to end in odd numbers, right? The only restriction now is we can't repeat. So you couldn't have 1, 1, 1, 1, right? So are we going to have less or more than we had in the previous one? Less, because we're taking away options, right? We can't repeat. So this is how I always deal with non-repetition. So we go 1, 2, 3, 4. Do it exactly the same, but we're going to circle numbers this time. So I'm going to start with the back number. I could start with the front number. It doesn't matter because they're both restrictions, and I have to start with restrictions first. But I always start with the back. I don't know why. So I have the options 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. Okay. So last time I just had 1, 3, 5, 7, 9. I had 5 options. Did that change? Still 5 options. But because I say that I cannot repeat, bless you, you have to pretend that you're keeping a number there to knock off an option, right? Because in the next one, when we go, we had 1 to 9, correct, at the beginning? But we're not going to have 1 to 9 anymore because we'll have to have kept one of the numbers in that last spot, right? So which number do you want to keep? It doesn't matter. Just whatever number you keep, you can't list it in the first blank now. So I always keep either the 1 or the 9 because then it's easier to list the numbers. But you keep 3, you keep 5, you keep whatever. I'm going to keep 9, and the way I show that I keep it is I circle it. Okay? You do this when it says you can't repeat. So now we're pretending 9's there. Could a different number be there? Absolutely. But just so that I can list my outcomes properly, I hold whatever one I want. So I'm going to hold 9, you could hold 3, you could hold 5, you could hold 1. It's just fine. Okay? But now because I held 9 here, I have 1, 2, 8 here. Because I've pretended to hold 9 in the last blank because I can't repeat. I can't use that 9 again. Okay? Couldn't use 0. Why can't I use 0? Let's see. It's in the first blank, and if it's in the first blank, it'd be a 3-digit number, so I can't count 0. So how many options is that? 8. Now I'm going to pretend to keep one. I'm going to keep the 8. Do I have to keep the 8? Could I pretend to keep a different number? Yeah, it's just easier to list if you pick the 1 or the 8. So everyone tells me in the next blank I have 1 to what? Yes. So most people will tell me 1 to 7. You guys caught it. I actually have 0 to 7, right? Why do I have 0? Why has it not been listed before this? Because it was a restriction on both blanks, actually. It couldn't be in the last one because then it would make it even. It can't be in the first one because then it would be a 3-digit. So we actually haven't used 0, but we couldn't list it either because it was restricted out. So we have to remember to bring it back. So we also have 0. So we actually have 8 options here. A lot of people will put 8, 7, 6, 5. That is picked equally as much on the test as this is, the correct answer. I promise you, if I was writing your question for you, or when I do write diploma questions, I would make the first error, common error, 8, 7, 6, 5, because you'll forget to bring the 0 back. And you can see why. It's very easy to forget, right? Now I have to keep one. I'm going to keep the 0. Pretend to keep the 0. I could keep any of them, but I'm going to pretend to keep 0. And then I have 1 to 7. So I have 7. So I could pretend to keep the 1, let's say. Now, I have the number 8019. Is that the only number? No, that was just one option, right? How many options are there actually? 8 times 8 times 7 times 5. How many odd 4-digit numbers are there that have no repetition? What's 8 times 8 times? That? Is it less than the previous one? Yeah, and it should be. We took out a whole bunch of options where we literally can't even have 1, 1, 3, 5, right? Because we can't have any repeating digits. So it knocks out a lot of options. Okay. Example 4. Car number plates in an African country consist of a letter other than I or O. Okay, we're dealing with letters. How many letters are there in the alphabet? 26. How many vowels? A, E, I, O, U. Sometimes Y never comes into these ever. So 5. What's the opposite of a vowel? Consonant. Most people forget about that word. Constant in math means the number without a variable. Consonant means not a vowel, right? So there's 21. So this one starts out with car number plates in an African country consist of a letter other than I or O. So I know my first blank has to be a letter other than I or O. I'll deal with that in a second. Followed by 3 digits. The first cannot be 0. So this one can't be 0. Does it say anything about the other 2 digits? Does it say they can't repeat? If it doesn't say it can't repeat, we assume you can. And then followed by any 2 letters which are not repeated. And to be honest, this needs to be specified better. It says followed by 2 letters that can't be repeated. It should say that this also doesn't affect, it's not affected by the first letter, that it can't be an I or an O. Okay? So just the back 2 numbers can't be repeated of each other. That's it. So on a diploma, they would have to be a little bit more, have to word it a little better than this. Because some people question, well, does the first letter actually affect the back 2? Because then it would be 25, 20.